So chapter 9, I'm really excited for because it's our trigonometry chapter. This is when we get to use the sine, cosine, and tangent buttons on our calculator, okay? And we'll get to do that after spring break. But leading up to spring break, we're going to be working with the Pythagorean theorem, special right triangles, geometric mean. All of it leading up until spring break involves radicals. So we need to go back to our algebra class in May and remember a couple things. Okay, so will you turn to page 1 for me? Wait, page 1. Does it look like this? 1 for me. Will you turn to page 1 for me? Okay.
What?
Are you good?
Your outfit's so like mathy today.
Thank you. I could have worn my necklace too, but I thought that would be too much. I know we don't have school on Pi Day, so I gotta kind of sport this on other days.
No!
I know, it's my favorite. March 14th.
Oh, Pi Day.
All right, so here's a list of perfect squares. What's the square root of 4?
2.
What's the square root of 16?
4.
What's the square root of 25? Okay. So you've worked with square roots before. Okay. What our goal today is to simplify them. Okay. And we're going to talk about multiplying and dividing them. So to simplify a square root, we need to break it up into 2 factors, one of them being a perfect square. Okay. So what's a perfect square that divides into 8? That divides into 8. Okay. So we know that the square root of 8 is 4 times 2, correct? Well, what's the square root of 4? So this becomes 2 square root 2. Because the square root of 4 is 2. Okay, what if I had the square root of 300? So 100 times 3 is 300. Ben, what's the square root of 100? No. What's the square root of 100? What squared gives us 100? What squared gives us 100?
10.
So we have 10 square root 3.
Wait, but what about if it's like 10 times 30?
So if you're going to do this, you're going to need to find a perfect square. So if you're not thinking of perfect squares, let me show you another way you can do this. If you want to think of this as 10 times 30, and 30 is 10 times 3, well, here I have 10 squared. So 10 squared comes out of our square root of 10, and then 3 is all by itself. It stays under the radical. If you need to solve it like that, that's fine. Okay, but I think that we are sharp enough to think of perfect squares that divide into our number. Okay, so what I want you to do is I want you to turn the page, and I would like you to simplify these 5 square roots, making sure you and your elbow partner agree.
That's what the next.
Okay, Brayden, square root of 20 simplifies to what? 2 square root 5. Okay, 20 is 4 times 5. So square root of 20 is 2 square root 5. Are we good with that? Okay. Presley, how about for square root of 75? What'd you get? Okay, so 75 is 25 times 3. So we have 5 square root 3. Okay. Clark, what about square root of 48? So you're saying that 48 is 16 times 3? Okay, so I have a question. What if you accidentally said, all right, well, 48 is 4 times 12, so we have 2 square root 12. Okay, you're not done yet because 12 has a perfect square, right? What's the perfect square that divides into 12? So you would have had to do this again with 4 times 3. And since the square root of 4 is 2 and 2 times 2 is 4, we end up getting the same thing, but you just have to do it twice. 4 is the perfect square that divides into 12.
Oh, so like,
Yeah,
if it's.
Yeah.
So what I'm saying is if you don't pick the biggest perfect square that divides into it, then you would have to do the process a second time. Okay. All right. The square root of 140. Nora, what did you get for that one? So this 140 is 4 times 35. Okay, awesome. So we have 2 square root 35. Okay, Ben, how about 600? Okay, good. So we have 100 times 6, so we have 10 square root 6. And 6 does not have a perfect square that divides into it. So yep, those are all simplified. Okay. Now, the big trick is going to come when we add and subtract. Okay. We can only add and subtract if we have like radicals. Okay. So if we have like the square root of 5 plus the square root of 5, those are like radicals. But the square root of 5 and the square root of 8, those are not like radicals. Okay. So we have to have the same number underneath our radical in order for us to be able to add them together. Now, look at this note right here. make sure you simplify all radicals before you start adding and subtracting things together, okay? So if, now, like in my first example, we can all see that all of those radicals do not need to be simplified, okay? But if we have one that needs to be simplified, we would need to do that first. So look at this first example. Square root of 7, square root of 7, and square root of 2. None of those can be simplified anymore. But which ones are alike? Okay, the square root of 7, those can be combined, but the square root of 2 is different. So we can take 6 plus 5 to be 11. And so we have 11 square root of 7 minus 5 square root 2. And that's all we can do. Okay, now, when we add these two right here, what do we have to do first? Okay, so we know that 50, what perfect square divides into 50? Okay, so 10 divides into 50, but it's not a perfect square. I want you to think of our perfect squares like 4, 9, 16, 25. 25 times what? Okay. What is the square root of 25? So this becomes 5 square root 2. I'll write that just so we can see it. So the whole term becomes 10 square root 2. Can you see that? Because we have to multiply the 5 with the 2 that was already there. Okay. Now, what about 3 square root 32? What perfect square can we divide into 32? Good, 16 times what? Okay, so we know that the square root of 16 is 4. So the square root of 32 can be written as 4 square root of 2. But we already had a 3 on the outside. So we're going to take that 3 times 4 to get 12. Do we now have like radicals? We sure do. They both are square root of 2's. So we take 10 plus 12 to get 22 square root of 2. All right. Put your pencils down. I'm going to send groups of 3 to a whiteboard. You are going to write down these 3 problems and solve them. Okay? So I'm going to give you a number of what board I want you to go to. 2, 4, 7. 2, 4, 7. 2, 4, 7. Good. 7 is the one that is kind of hanging through.
Yeah. I mean.
So yeah, you're fine.
Let's go, we got it.
Did you remember this 6 right here? Okay, so what I'll have you do is turn to the next page. And we're gonna write down these problems together. Okay? So, problem number 1, as I look around the room, it looks like you combined 5 square root of 6 minus 3 square root of 6 to be 2 square root of 6. But then plus 6 square root of 5 couldn't be combined with anything, so this is the answer that I'm seeing as I look around the room. Are you okay with that? Okay, write it down.
Yeah.
Page 4. Okay, so the second one, it looks like we need a little bit of work on. Okay, so 24, what perfect square divides into 24? 4 times 6, correct? So what is the square root of 4? So this becomes 4 square root of 6. Oh, no. I don't know how, where, this is a 3. So 6 square root of 6. Thank you, Clark.
Oh, yeah. Yeah.
Okay.
That was a good-
What I'm noticing is we're having some issues with which number to bring out. Okay. We take the perfect square and we evaluate it. The square root of 4 is 2. So 2 is now outside of the radical. Okay. Now, how about 54? What perfect square divides into 54? So 9 times 6, we know the square root of 9 is 3. So we end up with 21 square root of 6. Okay, so final answer, do we have like radicals?
Yes.
So we can say 27 square root of 6. Okay. And it looks like that went okay. Except for, I think group 7 forgot that 9 times 6 is 54. We had a 9 times 7 over there. It's okay. Okay, what about number 3? 8. What perfect square divides into 8? Okay, and we know that the square root of 4 is 2. So this becomes 4 square root 2. Good.
Let's go.
Okay, then over here, 48 is what? 16 times 3. And we know that the square root of 16 is 4. So we end up with plus 24 square root 3. Can we add those together? No, so that's where we stop. Look at that.